Hi everyone, welcome to Data Structures and Algorithms Session 4, Section 1, and this will cover the hash tables. And I will hand over to our study circle lead, Jaimit Wasawa, to go over the session. Thank you.
So, hello everyone. My name is Jamit Vasawa, and we have been covering different topics on data structures and algorithm. So, this is session 4.1, which is on hash table, and we'll try to cover hash table fully on two sections, this being one and the other one being two. So, let's get started with hash tables. So, what are hash tables? A hash table consists of an array in which data is accessed via a special indexed key. A primary idea behind a hash table is to establish a mapping between the set of all the possible keys and positions in the array using a hash function. So a hash function accepts a key and returns its hash coding or hash value. So keys vary in type, but hash codings are always integers. So in a way, you can imagine hash tables in a combination of arrays and linked lists. So when a hash function can guarantee that no two keys generate the same hash coding, the resulting hash table is said to be directly addressed, though it is rarely possible in practice. And the most hash functions map some keys into the same position in the table. When these keys map to the same position, they are called this is called collision, and we try to minimize these collision and address them in different manner and different method and apply different methods to do it. So there are some topics before discussing on hash tables that we will just briefly go over. One is chain hash tables. So hash tables that store data in buckets. Each bucket is a linked list that can grow as large as necessary to accommodate the collisions. Then open addressed hash tables that store data in a table itself instead of in buckets. Collisions are resolved using various methods of proving the table. Then selecting a hash function, the crux of hashing, by distributing the keys in a random manner about the table. Collisions are minimized. Thus, it is important to select a hash function that accomplishes this. Then collision resolution. Methods of managing when several keys map to the same index. A chain hash table have an inherent way to resolve collisions. Open address hash tables use various forms of probing. And we'll see the collision resolution and selecting a hash function in detail further. So some of the applications of hash table, which is database systems for accessing various types of database on or having an efficient random access to the database. Then symbol tables for the compilers to maintain the information about the symbols from the program. Then tag buffer, a mechanism for storing and retrieving data in a machine independent manner. So what happens in tag buffer is that the whole data whole array has to be transferred from a host network to from a host to the client, let's say. Then because of it being machine independent manner. Just
To put it this way, if you have two machines at different places, one is it is a network, right? In between there is a network, and if it is a what you call higher to lower byte storage versus lower to higher byte storage. So MSB to LSB and LSB to MSB. So there are machines which use, so Intel machine uses generally LSB to MSB, whereas examples of what you call the mainframes and PDP-11s and mini computers, they used to store high to low, so MSB to LSB. So the orders are reversed. So if you have a structure, say structure consisting of two or more what you call elements, the order will get reversed if it goes from one end to other end, unless you are able to handle the byte order. and that is why you tag it. So you tag it as, say, field 1 F1, field 2 F2, field 3 F3. When reaches the other end, you may get it F3, F2, F1. You may have to reverse it to get F1, F2, F3. So you use the tag mechanism to figure out, and that is the tag buffer, use of tag buffer. Same way, I would also put it in the front. Database generally maintain tables, uniform tables, the rows and columns. So when you talk about, in this case, the positions in a chain table, that may not have the uniform arrays. So that means if you have a linked list, one may contain 3, one may contain 2, one may contain 1. That is a non-uniform. Uniform means if you have 3 in 3 rows, then the column becomes 3 columns, 3 rows, right? 3 into 3, 9 elements. So you have 9 elements within a 3, what you call rows, or 3, number of elements is 9, number of columns is, which is equal to number of columns is 3. So if we take m by n, suppose m we call as the rows, and n we call as the total number of elements. Total number of elements is 3 into 3, 9. So the load factor of the hash table, or the chained hash table, as we referred, will be 3, assuming it is uniform. It is non-uniform, then you may have in one position, there is one row, there may be 4. In other row, it may be 2. So how you distribute the key? Generally, the hash values are always integers. Okay. Remember, hash value or hash code is always integer, whereas key value may be not integers. Like example, it could be string, but you can map the key values into some number, and corresponding to that number, when you do a hash of the key, you get a code which is again integer. So you can do that, and that's the key information. And Jamie, do you have the diagram for the
Actually, the extension is there further.
No, did you include the
Yeah,
hash table? Can you go to that?
this one.
Yeah. Point this and then initially explain something, what you were continuing before you continue on this. Just explain this table.
So you can see that the chain hash table is in a combination of array. So what we usually do with arrays is place them horizontally, but we will, for convenience of understanding, we'll place them in a vertical manner, and then each of the buckets or the elements that will be stored will be in form of a linked list, where each element will be stored in buckets or
One sec. What is buckets here? Buckets means rows.
yeah.
In this case, bucket means rows. Remember that. Easy to remember. So row has more than one element. Like first row has zeroth row, what we call HK0. Keys, we call key 0, but it has got one element. HK, there is key being 1, it has got 3 elements, right? So important to understand that the row bucket here means the rows, and number of elements. So bucket we call as M position. So M is 1, 0, 1, 2, 3, 4. 5 positions are there here. Whereas N number of elements in this is 1 plus 3, 4 plus 1, 5, 2, 7. 7 elements in 5 positions. 5 positions is 5. 1, 0, 1, 2, 3, 4. That is 5. 5 keys are there, but there are 7 elements. So load factor is greater than 1, obviously. So that means every bucket can be loaded with more than one element. In this case, the second which is 0, 1, 1. Bucket 1 has bucket 0, bucket 1, bucket 3, bucket 4, bucket 5. Bucket 1 has got 3 elements, which is chained. Obviously, chaining is the way to resolve the collision. You don't find key 1 and key 2 colliding to the same element, right? That's important. So there is no interconnection between two separate rows or two separate positions. Yeah, go ahead. Now
Uh,
explain what is a hash table, chained hash table.
yeah, yeah. So you can see that there is some function h for whose the value k, which goes to the position 0, and that is how the has been array has been filled from 0 through 4, with each of the elements stored in buckets. So which is a linked list. So if there are more elements, you can see that there are for HK of 1, we have 3 elements. And so there are so in that manner, a linked list is used to store multiple elements for. Yeah. So for applications of hash table for data dictionaries view, so data structures that support adding, deleting, and searching for the data. Then associative arrays consist of data arranged so that the nth element of one array corresponds to the nth element of another array. So these are some of the applications of the hash table. So as for the description of the chain hash table, almost most of the explanation has been covered in a way. So I'll just read out a few of the points. So a chain hash table fundamentally consists of an array of linked list. To pass a key to a hash function is called hashing the key. So we can hash the key for insertion, deletion, and to lookup. So whenever we want to insert a key, we hash its key and go to the position of the element that we want. Then we insert the element at the head of the linked list. Kind of similar operation for the deletion and for lookup as well. And then a chain hash table is not limited to fixed number of elements. However, the performance degrades if the table becomes too full, which basically means that we cannot have so many elements that it becomes tough for us to get the element in an overly populated linked list.
One thing is that goal is random access and the other is uniform. So if you are able to get uniformity, there is the number of linked lists is minimized, that is load factor, right? So if the load factor is uniform, as well as when you do a mapping of hash of the key, you always get a unique position. Yeah, go ahead.
So collision resolution. So as discussed before, also or mentioned that for what we call is collision is that when two keys map to the same points. So for resolving that, one way the hash table deals with the collision is that it puts the elements where the collisions are happening into the same buckets. But what happens is that if there are excessive collisions happening, then it can take long. It can make the linked list longer and longer and take longer and longer time to access the element as well. So, so what we want is we want the whole table to grow in a same rate and in a uniform manner, which we'll shortly call uniform hashing, where we'll distribute elements about the table and are stored in uniform and random manner. So in practice, it is usually it can be approximated, or you can say that uniform hashing is an approximated thing. So as also mentioned before, the load factor, which will help us to determine how many elements uh, and how many elements we want to insert, should be a good number for having the accessing for accessing the elements as well, if we insert a certain numbers of elements. So load factors of a chained hash table indicates that the maximum number of elements we can expect to encounter in a bucket, or assuming uniform hashing. So the formula is alpha equals to n by m, where n is the number of elements in the table and m is the number of positions into which the elements may be hashed. So you can see the uh, example of m equals to 1699 and n equals to 3198, where we get the value of 2. So if we because we are getting the value of 2, we can expect that we have 2 elements per bucket. But as we said that it's an approximated thing, so it's around the value of 2 that we will find. We can find 1 element also, and we can find 3 elements also. If the load factors value if is below 1, which means that we expect only 1 element at each position. Now this whole load factor helps us in determining the a good hash function. So uniform hash function is approximated, so it depends on the selection of the hash function. So selecting a good hash function. So the goal of the good hash function is to approximate uniform hashing. So that is to spread elements about a hash table in a uniform and a random manner as possible. So we have h of k, which is value is x, where h is the function, hash function, k is the key which will be mapped to the position x in the hash table. So let's say there are 3 values, which is sample PT, sample pointer, simple pointer, and sentry pointer. Now, not so good way to put these words is that we can take the first element and the last element, which will create many collisions. But what we can do is we can have uh, a way in which these 3 words show changes, and let's say from position 2 to 4. So we can take those and put it into hash function, which further makes them unique, and then put them into a 4 byte integer, and store them, and make a have them as a key. So 2 methods of hash function is first is a division method, where h of k is k mod m. So typically we should avoid values of m that are powers of 2. This is because m equals to 2 raised to p. H becomes just the p lowest order bits of k. Uh, Basically, it means that when dealing with binary values, we there will be many lower order bits of k uh, with the power of 2. So for creating more unique, it is better to stick with a prime number and have a uniform values of k for k. Then next is a multiplication method. So we multiply the integer k by a constant a in the range 0 between range of 0 and 1, and extract the fractional part. Multiply this value by the number of positions in the table m, and take the floor of the result. Typically, a is chosen to be 0.618, which is the square root of 5 minus 1 all divided by 2. So there are 2 methods, division and multiplication, for the hash function. So now let's look at a hash function, which will be employing a division method for strings. Uh, First is a chain hash table, so CHTBL init, which initializes the hash table. Uh, the, so for the people who are new to this, this is the this is the pattern that we have followed till now for for constructing a separate header file and having the functionalities in them. So these are related to that. So ch hash table init initializes the hash table, then destroy for deallocating the memory, then insert for inserting the element, remove for removing the matched element, or the matching element, then look up for uh, determining whether an element matches the data in the chain hash table specified by the hash table or not. Then size means size of the hash table. So now let's look at the hash table. So so this is the hash table that uh, uh, sorry, uh, this is the program that will uh, that is a that is used for hashing strings. So this is the header files that will be using. There's the initialization of it. Then these are the executions that will made uh, on the bit level for hashing the string or the input string, and then yeah. So as also this mentioned here, that this will correspond to the actual size of the table. So this is just a small uh, representation of the hash function and for strings. Next is so yeah, just a second. Now so um, so this is the header files that we discussed some of the components on that slide. So this is the list.h that we will be using. This is the standard library. Then this is the whole header. Yeah, so we'll be starting with defining the structure of the chain hash table with the buckets for storing the element, the pointers for the keys, then a match for matching the values of two keys because for accessing the element, then destroy for deallocating the deallocating the memory uh, used, then size for size of the table, then table for traversing, then then some as we have discussed some of it. So ch table init basically initializes the table, initializes the chain hash table, then destroy for destroying the hash table using pointer stdl, then insert for inserting, removing lookup, and size.
So can you go back on that?
Yeah.
So here the important thing is the data structure. That is buckets. When you say you got number of buckets,
Yeah.
each bucket is an array which has a key, and key points to a value, and there are multiple keys because you got every key points to another key key 1, key 2, and then data. So this is representing a variable length row or a variable length bucket, so that you are able to have the buckets, and list of buckets forms your table, because table is not uniform, right? That's the chain table. If it is uniform, in that case, then you will have constant number of keys without linked list, right? That's the different. So data structure is important, and the public interfaces to operate on the data within the table using the hash table. That is why it is list.h. And so, of course, go ahead, continue further what you have on the code. Welcome, Kevin.
So this is the dot C. First we discuss the dot h file or the header file, and then we'll include those in the main C program, as we have the library already defined libraries of standard library and string library. Then list dot h and CST tbl dot h that we just discussed. So we'll be using the in the init function for on the chain hash table, allocating the space for the hash table. If in case it's a failure, it will return the value of -1. These are the values for these are the steps for initializing the buckets. Then encapsulate the function and initializes the for the size of the deal. Then for destroying or deallocating the hashed bucket, we'll use a for loop and iterate through to get to the desired element. Once we get it, we use the HTML pointer for pointing at the table, and then set it free. Then for similarly for the chain hash table of inserting the element. First, we'll check whether the element is present in the table or not. If it is not, then we'll go further and we'll hash the key first, then insert the data into the bucket and return the retrieval value. Then we have remove for removing the element. So this is for, just briefly stating this list element is defined in a list.h function, which takes the element the previous pointer, element pointer previous pointer, and bucket for story temporarily holding the value. So firstly,
clarify, is it a doubly linked list?
No, single linked list.
Single linked list, okay.
Yeah.
Just the previous and the next. What do they refer to then?
No, there is no next.
Oh, okay, there is no next here.
Yeah.
Okay.
So then we hash the key, search for the data in the bucket, and remove the data from the bucket. So then so -1 is just basically for the unsuccessful getting out of the block. Then CST will look up for looking out for the desired value, where we use the for loop for traversing through it, and if look for passing back the data from the table. And if the retrieval was unsuccessful, it will return a -1 value to it. So, so yeah, this was this was the one of the session for the hash tables and some of the discussions of the topics related to it. There will be a continuing session for hash tables, which will uh, completely cover the topics that are mentioned in the book. And yeah, so thank you for listening.
Yeah,
And
one
yeah,
question is, uh, what is the distinction between division method and multiplication method?
oh
Uh,
yeah,
is there any specific example? So let's say we have 4,500 elements.
yeah.
So what would be a good number for division method?
So for division method, it's better to stick to the prime numbers.
Yeah.
Uh,
So
uh,
prime number should be between what and what? Example, 4,500 prime number.
it
If you take 2 to the power 10, we get 1024. 2 to
okay.
the power 11 is 2048. Suppose we can support a load factor of minimum 2 or greater than 2,
Yeah,
then we have to choose somewhere between what? 1024 and 2048.
yeah.
So what would be the prime number? So example, if 1699 is the prime number, okay.
Okay.
So there are 4,500 elements. If you divide by 1699, you get a factor of 2.6. So for, you said you should not select a
Uh,
in
in
the
the power of
division
two.
method. In division method, you should not choose a multiple of 2, correct, for m.
Yeah,
So m is the buckets, right? M is the rows or buckets.
yeah,
So you should not choose uh, a 2 to the power, like 2 to the power, let's say 1024 and 2048. You should not select 1024 or 2048 as the buckets
okay.
because they are power of 2. You should prefer to have a prime number.
Yeah,
So any number prime number between 1024 and 2048 is a good candidate because you have 4,500 elements and you want somewhere in the middle, which is, if you take 4,500 divided by 2, it will be around 2,250, correct?
yeah,
2250. So between 1024 and 2048, if you choose a number, you will get a better than 2 factor.
yeah.
So that is for division method. What happens to multiplication method?
So the
Multiplication method, you have a factor and the a should be less than 1. It should be between 0 and 1, whatever you multiply, right? So h of k, h is nothing, hash function. K is the key. H of k, you want it to be something like you mentioned some 0.618, right? Which is some formula
yeah,
arrived at based on the root 5
yeah,
and minus 1 type,
yeah,
right? Root 5 divided by 2 and minus 1 or something like. Root 5 is something like 0.7
yeah,
and then 0.718 and minus 1, that gives you 0.618 or something like that.
yeah.
Okay. So in the multiplication method, uh, what you are doing is you are trying to achieve just h of k equal to whatever the bucket's size multiplied by the key and the factor a, and you take a mod 1 of it.
Okay.
Mod 1 means what? Mod 1 means any number with a divisible, it should be integer. That's all, right?
Yeah.
If you do mod 2, it is a even number. Mod 1 means it is an integer. So when you say h of k uh, equals m of k mod 1, and you already have defined a as 0.618, right?
Yeah.
So that means what you are doing is you are taking the key, whatever the key is 1, 2, 3, 4, let's say whatever, right? If you have 4500 element, then the key will be 4500 up to, correct?
Yeah.
So whatever your key value is there, number of, so in the case of division method, you were depending on m.
Yeah.
You have to define m properly. Here you don't have to worry about m. Whatever number you want, you can put m, k, because this is constant, right? So because your a is less than 1. So what I mean is your loading factor is less than 1.
Yeah.
So that means the number of keys is much greater than number of positions. So therefore there are many keys available for placing. So you will have less than 1, right?
Yeah.
You can have element less than 1, and even if one of them goes greater than 1, it's okay. But loading factor is low.
Yeah.
So in multiplication method, you gain the advantage of you don't have to worry too much about the what you call the result of the hash function, because keys are unlimited, right? Compared to keys are greater than the number of elements.
Yeah.
So if you have 5,000 keys and you only have 2,000 positions, then you know that many of the key will be empty.
Yeah.
So the advantage of multiplication method is you don't have to worry about the number of positions or number of rows, because you have enough rows to fill in. Okay.
Yeah.
So I just wanted to stress that because that was not clear earlier. Just to, even though it was stated, but it's a bit of a, unless you show some numbers, it is hard to understand the difference between division method and multiplication method. So that's one thing which I wanted to bring. And did you have any other questions, Saroj? Saroj, go ahead if you
No,
have any questions.
no, currently no. Actually, yeah. Basically, these algorithms and these things, I am new actually because I have
Mhm.
not much gone into that and not practiced much. Yeah, I'll go
Mhm.
through and any question next class can discuss.
Yeah, we will also add the questions and answers on the related topic in the next
Okay.
session, so that we
Mm-hmm.
may have some few more questions we'll add so that you can easily understand. Of course, the direct addressable table you understood, right? Direct addressable table is you got one-to-one match.
Yeah, yeah.
That means if you have a key, there is a corresponding value you can. Hash table is directly addressable. So if you know the key, you know already where the position is of the element. But if it is not directly addressable, that means then there is multiple entries, right? It is indirect. Indirect because you go to the key, get the key position, and from key position you go to the position of the element, and that may be linked again to another element, to
Okay.
another
So,
element,
so,
right? So it is
so
not direct,
basically,
it is indirect.
yeah. So basically, hash table, you're saying about it will always store integer means.
Yeah, a key is always a so not key. The index, that is the hash
Okay,
number,
okay.
is always
Always
integer.
integer.
So the
Hmm.
position uh, in the position where you, like you have got yeah, in this case, so here the position, this is 1 2 3 4 5 6 7, right?
Mm-hmm.
Now if you bring something in between, then you will just move it, right? So basically what it means is you got numbers. It has to be number, right? Otherwise, how do you index it? So
Okay.
the content is different from the position, right? Position is here, doesn't mean the content is same, right? That's an index only. So
Okay.
hash
Index.
index is always a number. Key may not be a number. Key may be a string. So
Hmm.
example, we had taken example of symbol table. So what happens in a symbol table? You write a program and your compiler scans through the symbols and then creates
Hmm.
corresponding how it should be. Like example, you had a variable, three variables which first and last being same, right? And sentry pointer, simple pointer, something else pointer was there, right? So S and R are so if you are going to take a first and last character and index it, example pointer, simple pointer, sentry pointer. So if you are going to take this string, the key if you take is S and R, first and last character, then you are going to get, there is going to be a collision, right?
Yeah.
So instead of that, if you use some other position, like let's say fourth position, fourth is fifth position, let's say 1, 2, 3, 4, 5, L. 1, 2, 3, 4, 5, L. 1, 2, 3, 4, 5. So still there is a clash. So you have to take 5 and maybe you can take 7. So 7 is 1, 2, 3, 4, 5, 6, 7 P here. 1, 2, 3, 4, 5, 6, 7 P here. So again a clash. So 5 and 7 won't do. So maybe you have to take a 2 and 5. 2 is A, 2 is I, 2 is E, right? So A, I, E are different. So 2 is good itself. 2 alone itself is good, but you take one more. Let's say they chose 4, right? They presented 4 in the when Jamie spoke. He spoke about 4. So 2 is unique in this case. So you must have uniqueness. So when you are scanning a symbol table, which is you are writing a program and the program has these variables defined, right? So a compiler will scan the symbols and put it in a symbol table. So when it puts in a symbol table, that is using hash table. And so if you properly key, which is a string in this case, if you are converting that to a number, if this is number 1, this is number 2, this is number 3, then there is no collision. If this is number 1, this is number 7, this is 19, then there is no collision, right? But if this and this have same number, then there is a collision. Like example we said, if you take first and last, all of them are 1. The key value is 1, right?
Yeah.
S and R, S and R, S and R. So key value is 1. So your symbol table will have clashes. So the idea here is to make sure that any application, like database is an application, associate array is an application, a symbol table is an application. Go to the application, Jamie, you had shown some applications. Yeah, so we had seen database systems uses this, hash tables, symbol tables uses, tag buffers we talked about, which is machine to machine transfer. Data dictionary is example. So associated error. So these are some of the system programming examples. Lot of hash table is used in system programming because you have to deal with the operating system level, right? And so hash
Okay.
tables are important for, of course, they are also good for application because it does uniform searching, right? Able to search something uniform time, performance wise, it optimizes. So there are some advantages to it. So we'll cover some more things. Jamie, what do you plan to cover next time? You
Actually, some of the remaining ones
so
that
you are
I have for open addressed hash tables.
okay. Okay. So we did not cover open address hash table
No,
interfaces.
no.
Okay. So you only covered the chain table. So
Chain
there are
table
two
and
types.
one of the hash functions that are
Yeah,
mentioned.
yeah. Hash functions you covered. Yeah, hash functions are nothing but a kind of a um, you can say
Entry.
a mapping formula.
Okay.
It maps the key to key which is which can be string, which can be in anything, right? Key you don't have. Like example, we can talk about a library, let's say. If you're a library and you're issuing books, and so the mapping is between the book and the member who gets the thing, right? So if there is a member, let's say uh, Saroj and uh,
Yes.
Amit,
Okay.
let's say you have two members and we have four
Mm-hmm.
books. Now, if these four
Okay.
books is book one, book two, book three, book four. If I issue book one to Jaimit and book two to Saroj, then no problem because they are one to one. Now I go issue another book, book three to Saroj and book four to Jaimit. Now we have got what? We have got two books issued to each of the members. So what happens if I give you a member? If I give you a book, you can definitely figure out whether it is uh, Jaimit or it is Saroj, which book is issued to. But if I tell me Jaimit and tell me what book, then your mapping is multiple, right? Jaimit has two books, so he has got book one and three, and Saroj has got book two and four. So then uh, key is colliding, correct? If you
Yes.
have
Yes.
K1, K2, K3, K4, if they are
Mm-hmm.
colliding to same John or same Jaimit and same Saroj, right? So there is a key collision.
Okay. Okay.
So then to avoid collision,
Yeah. So we are saying actually. Yeah.
mhm.
So you are
Yeah, go
saying
ahead, sir.
actually basically every place we are in, yeah, every place we are using those hash table. So
Correct,
when we are developing a product, it may be a
correct,
database or it may be
mhm.
any type of product. Okay, okay,
Correct,
got it.
correct.
Yeah.
So the important thing is we are using, these are the applications where hash tables are used and they are part of the language actually. Lot of languages
Yes,
use it.
lot
All
of them.
languages use
Correct.
symbol table for compilation or interpretation. Tag buffer is for
Okay.
machine to machine communication or client to machine and machine to client. Data dictionary is always required because you want indexing. Associate arrays,
Mm-hmm.
if array is there, another array is there, they are associated. That means what? One entry in one array has a association with another entry in another array. So two arrays are there, but they are associated. So association array is defined in all languages. Most of the languages define it. All scripting languages are associated arrays. But some of the languages provide instead of associated array as a uh, element, as a part of the language, they provide as a mapping, or some people call it maps. Some of the languages call it as libraries. So it can be map, it can be hash, it can be hash table. So the same hash table can be uh, uh, using different terms in different languages. That's why some people call, like in Python we have got dictionary, right? So the same thing may be called as map in Java, but they all belong to the same hash table usage. Key value. Question is, what is the key? What is the value? Is the mapping uniform? Is the loading factor higher or lower? And is it chained or is it open table? So we'll talk about open table next time. Open table is nothing but a fixed table. That means it is like database uses number of rows equal to number of rows and number of columns, which is fixed, not variable. So if I have a table with 10 columns, that means row can be many, but the columns are fixed. That is called as row table. Then columnar based tables are there where columns are fixed and rows can be variable. So there is a variation in column based or row based, but generally database uses open table.
Okay.
Okay, I
Okay.
think we have covered sufficiently. Unless you have any other question, we should close. And I will just